In this video, we're going to take a look at the dot and cross products of vectors. So in each of my boxes here, I've kind of given you the generic formula for those products. However, I'm going to give you an example for each of them. So looking at the dot product, I want to show you really what we're doing is we're multiplying the first components. We're multiplying the second components. If we had third components, we'd of course multiply those and then we add them all together. So if we're looking at vector u and vector v, I'm going to take those first components and multiply them. And then I'm going to take the second components and multiply those. And then I will get a numeric answer. So 3 times 4 gives me 12. And -6 times -2 gives me 12 also. So my dot product, my inner product as it is often referred to, is 24 here. And so I want you to notice, because this is going to be different when we do the cross product, that the dot product gives you a numeric answer. And really, what are you doing? You're multiplying those components. You're multiplying the first components, multiplying the second components, multiplying the third components if we had them, and then you're adding those products together. Now, the cross product is a little bit different. So the cross product only works when you have 3 components, and you're going to do what is called a determinant of those of this matrix that's created. Now, row 1 is always going to be the unit vectors, I, j, k. Row 2 will be one vector. Row 3 will be the second vector. And I'm going to show you just a recap on how you do a determinant. So let's set up our cross product here. Remember, row 1 is the unit vectors. Row 2 is one of the vectors you're given. And row 3 is one of the vectors, or the other vector, I should say. Now, when you do a determinant, if you look in the text, you're going to see that there's a whole, like, we're canceling out row 1, canceling out column 1, and then multiply across. And I just find it's easier to do a little bit of a shortcut. So I want you to take column 1 and rewrite it again here. And then I want you to take column 2 and rewrite it here. Okay, now you're going to multiply along the diagonals. So I want you to see, I'm going to multiply this diagonal. Notice they're going down. That's important. So we're going to multiply these 3 diagonals and add them together. So first, multiply this diagonal. I times -2 times -6. That gives me 12i. And then I'm going to add and then multiply down this diagonal. J times 3 times -4, that gives me -12j. Now multiply on this diagonal. K times 1 times 5 will give me 5k. Okay, so far so good. Next, we're going to multiply the other diagonals, but this time we're going up. Multiply that diagonal, and that diagonal, and that diagonal. Now, when we go this direction, we subtract whatever answer we get. So let's see, -4 times -2 gives me 8 times k is 8k. So I'm going to subtract 8k. And then 5 times 3 will give me 15 times I. So I'm going to subtract 15i. And -6 times 1 is -6 times j is -6j. So I'm going to add 6j. See how I changed that sign? All right, so my cross product is simply to combine our like terms. So 12i minus 15i gives me -3i. -12 plus 6, or sorry, -12j plus 6j gives me -6j. And then 5k minus 8k gives me -3k. And so my cross product, I want you to notice, is a vector. Remember, the dot product's a number. The cross product is a vector. Now let's put that all together in example 3 here, where I have vector A, vector B, and I'm going to find A cross B. So I'll set up my determinant. Remember, row 1 are the unit vectors, and row 2 would be vector A. Row 3 would be vector B. Now you may ask yourself, does the order matter? The answer is yes. The cross product is not commutative. So that means that I have to make sure that whatever vector is listed first is in row 2, whatever vector is listed second is in row 3. Let's go ahead and rewrite column 1 and column 2. And we'll multiply along the diagonals here. Remember, when we go down, we leave the signs, we just add the products. So let's see, our cross product, I times -2 times -6 gives me 12i. J times 3 times 4 gives me 12j. And k times 5 times 7 gives me 35k. All right. Now, when we go the other direction, remember, we're going to change the signs, or you might think of that like subtracting. Okay, so this is 4 times -2 is -8k, so I'll add 8k. 7 times 3 is 21 times I is, oops, I got to do it -21i because I got to change that sign. And then -6 times 5 is -30 times j, so I'll add 30j here. Finally, we just need to combine like terms. 12i plus -21i gives me -9i. 12j plus 30j gives me 42j. And 35k plus 8k gives me 43k. So again, remember that my cross product answer is in a vector. So let's look then at my dot product. So remember, this is where we're going to multiply the components. So 5 times 4, so my dot product is 5 times 4 plus -2 times 7 plus 3 times -6. And remember, my dot product should give me a numerical value. And so A dot B looks like 20 plus -32. So A dot B can be -12. So I hope that helps with our dot product and cross product of vectors.